Rationalizing the denominator. So first of all, what is a denominator? Well, when we have such expression 2 by 3, this is a numerator and the below number is a denominator. So what is the rationalization? What does it mean? It's a process, it's a way of converting a denominator with the square root term to an equivalent expression whose denominator is a rational number is called as rationalizing the denominator. So I'll put it with an example. That's the best way to learn anything, right? I have this particular expression with the root in the denominator. I can convert this to an expression like this, wherein there is no root in the denominator but the numerator. This is rationalizing the denominator. Okay, so this is equivalent. That is, these two are mathematically, in terms of value, their output is the same. They look different, yes. So this is an equivalent expression and this is a rationalized version. Okay, so rationalized what? Rationalizing the denominator. So next question is, I'll explain why they are equivalent. Why are they equivalent? And how do you rationalize something? I'll explain that also in time, but we'll try to understand. They've used the expression equivalent. What does it mean actually? Well, 1 by root 10. Let me take that. We have 1 divided by, okay, not that. 1 divided by root of 10 is 0.3162. Approximately 0.3162. So let's take up root of 10 by 10. So using the calculator, again, root of 10 divided by 10 is 0.3162 again. This is approximately equal to 0.3162. So in both this case, we have the same output, same number. So these two are equivalent because their output is the same. So this set of expressions are equivalent. So this process of converting from this particular expression with a root in the denominator to one without root is your rationalization. And the expression you get finally will be an equivalent expression. Reason being, when you solve it using a calculator, end of it you'll get the same answer. Okay, now how do you rationalize something? So I would begin with the smallest possible example. Okay, before that I have to tell you one big logic. It's with the help of one. Why 1? Because 1 is a multiplicative identity. What does that mean? We can multiply 1 with anything and get back the same thing, right? 1 by root of 10, I can rewrite this as 1 by root of 10 into 1. I can multiply any expression and get back the same thing. But what is the point of this? Well, the thing is, 1 can be written as 2 by 2, 21 by 21. It can be written as 141 by 141. It can be written as root of 10 by root of 10. Does it make sense? Because they end up cancelling each other and getting back 1. So in place of 1, I'm going to write root 10 by root 10. Why that? We'll see. So I picked up root 10 by root 10. How will this help? 1 into root 10 is root 10, while root 10 into root 10 is root 10 the whole square. Okay, how is that? A to the power of n into a to the power of m is a to the power of n plus m with this logic. So root 10 square will get cancelled and we have root of 10 by 10. This is the logic. So I was able to get an expression which is equivalent without the denominator having the root. Okay, so this is your logic. So a small note for people who right, get confused with all of this. So root of any number is nothing but a to the power of half. So root of a the whole square is a to the power of half into 2 as per this formula. Okay, so what happens? 1 by 2 and 2 gets cancelled and we have a to the power of 1. So that's how we are able to cut root and square over here directly. So you need not show this many steps. You can just remember and make use of the right math. So you will get not only such expression 1 by root 10 and all of that, you will get complicated expressions like a bit complicated, something like this. So whenever you get any expressions like this, all we have to do is, instead of root 10 and by root 10, we will multiply with root of 5 plus 2 divided by root of 5 plus 2. Why particularly this expression? Well, we have root of 5 minus 2 in the denominator. So we have to take the same set of numbers with a different sign in the middle. So how will this help? We get to use a minus b into a plus b, which is a square minus b square formula. Okay, so if you have any kind of expression like root of 11 minus 5 divided by root of 41 minus 3, all you have to do is forget about the numerator, let it be there. Whatever is there in the denominator, write that with a plus sign and then do this and you are done. Okay, same expression with the different sign, we get to make use of this particular formula and get the answer. So don't worry, we will be doing a few examples with such kind of numbers, expressions. So the process of rationalization is as simple as this. Let me give one more example. Root of 11 minus root of 6 divided by root of 3 minus 10. All you have to do is root 3 plus 10 divided by root 3 plus 10. Again, your numerator can be anything, like say only root 11 is there. Your root 3 itself is there. It can be anything in the numerator. Look at the denominator, put brackets, get a same expression but change the sign. And you get to use this particular expression and you get to solve the math and you're done. So this is a process. Okay, so again, rationalization is getting an equivalent expression without root in the denominator. This is the process of rationalization. So please pause, have a look at it and do copy it as well.